Lots of people are tempted to call the process where we find concavity in points of inflection the second derivative test. And we do use the second derivative for that, but that's technically not the second derivative test. The second derivative test is a way to use the second derivative to find max and mins. So the first derivative test uses the first derivative to find max and mins. We do that with that chart. The second derivative does it with find max and mins with the second derivative. The first thing we need to do is find where the max and mins might occur, and that's the same as before. Max and mins are going to occur where the derivative equals 0 or doesn't exist. So we'll find the first derivative, set it equal to 0. I'm going to factor out a negative 15x squared. So I have three places where I might find critical numbers. I get 0 from here and then plus and minus 1 from here. So those are the three places I might have a max or a min. Now I need to figure out if they are max and mins and which one they are if they are one. And this is where the second derivative comes in. So let's take the second derivative. We get negative 60x cubed plus 30x. I'm going to factor out a negative 30x, leaving me x squared minus 1. Excuse me, 2x squared minus 1. And we don't need to set that equal to 0. Sorry, getting ahead of myself. Or thinking of something else. Anyway, now that I have my second derivative, what I need to do is take these three numbers, negative 1, 0, and 1, and plug them in. So if I plug negative 1 into that, I should get positive 30. If I plug 0 into the second derivative, I get 0. If I plug positive 1 in, I get negative 30. So here you have to apply what you know about the second derivative. Here we're told that if we plug negative 1 into the second derivative, we get 30, which is a positive number. A positive second derivative implies that we are concave up. Okay, well think about what a concave up picture looks like. It would be like that. Well, a concave up must mean it's a minimum, because there's no maximum on a U shape, there's just a minimum. So this tells me that there is a minimum at x equals negative 1. Now when I plugged in 0, I got 0. That's neither positive nor negative, which probably means it's a point of inflection. I'm not guaranteeing that, but probably means that. It's certainly not a max or a min, because we're neither concave up or down, so it can't be a max or a min. So 0 is not going to be a max or a min. Now if we plug in positive 1 into the second derivative, we get a negative number. And we know a negative second derivative implies our original is concave down. So think about the shape of concave down. That means we must have a maximum. So we have a maximum at x equals 1. So that's the second derivative test and how you can use the second derivative to determine where you have maximums and minimums.